Problem 1 in the lesson 60 solutions, we've been given that circle R and that KM, so from here to here, is perpendicular to LO. Prove that angle KLM is congruent to KOM, and use the side angle side theorem in your proof. That's also suggested there. And what are some things we can show on that? Well, looking at these two triangles here, we see two triangles, and we could say that KM and KM are congruent by the reflexive axiom. We could say this and this segment are congruent. LM and OM are congruent by the perpendicular bisector of a chord, because LO is a chord inside that circle, and that perpendicular bisector of a chord theorem says that those would be congruent. And then it's perpendicular, so those angles are 90 degrees, and we could prove the two triangles are congruent by side angle side, and therefore this angle here, KLM, must be congruent to KOM by CPC TC. So making that sketch and marking things off on it is always a very good way to get your bearings and to think about how you're going to prove that those angles are congruent. So write down our given information first, as always, and our reason for writing that. Circle R and KM is perpendicular to LO. That was given to us. Then LM is congruent to OM because of the perpendicular bisector of a chord theorem from lesson 60. And then KM congruent to KM, that's our reflexive axiom, Euclid's axiom 4. Therefore, the two triangles are congruent by side angle side. Those two angles are congruent by CPC TC. Corresponding parts of congruent triangles are congruent.